All right, this is all about implicit differentiation, which is, this is a technique for finding a formula, for y prime. So far you've been doing explicit differentiation. An example, y equals 3x squared plus 4x. Explicitly finding y prime, you use y prime is 6x plus 4. So that's explicit. Implicit, you're going to be doing, you're not going to be using exactly like this. So what you're going to be doing for implicit is it's going to be using the chain rule. Just as a reminder, oops, that's chain. Remember in class, if you have, if u is some function of x, then finding the derivative with respect to x of things like u to the n is n u to the n minus 1, and then we needed to add on that u prime. Or say we wanted to do e to the u, its derivative, this is going to be e to the u times u prime. And then we just learned logarithms. Ln of u is 1 over u times u prime. So we were using the chain rule. Well, in implicit, instead of using u equals f of x, we're going to be assuming y is a function of x. So in implicit, differentiation, we assume y is a function of x. And then finding the derivatives with respect to x of things like y to the n is going to be n y to the n minus 1 times y prime. And the derivative with respect to x of e to the y is going to be e to the y times y prime. The derivative with respect to x of ln of y is going to be 1 over y times y prime. So what we're going to be doing is we're going to be treating this y's just like we did u's in the chain rule. So with that said, I'm going to show you a PowerPoint presentation I did a while back, and there's a couple different notations, and I do a little bit of implicit versus explicit. So here it goes. Now, you know what? Before I do that, let me just do an example. Say I have x squared plus y squared equals 4, and I want to find y prime. The idea is you take the derivative of both sides with respect to x, and you treat y prime as a variable. So I'm going to do the derivative with respect to x of both sides. And so when I do this, I use the fact that the derivative of two things added is each individual, so it's going to be 2x. That's the derivative of x squared. And then on that previous slide, I just showed you the derivative of y squared. We have to use chain rule, so it's 2y to the first power times y prime, chain rule. And the derivative of 4 is just 0. So then I get 2y, y prime is minus 2x, y prime is minus 2x over 2y. The 2's cancel, and you get minus x over y. So you see when you're doing these, whenever you're doing a derivative with respect to y, you have to remember chain rule and include the y prime, because we're assuming y is a function of x. And when we're solving, and when we're done, we're going to get some expression that has y primes in it, and then you treat y prime like a variable and you solve for y prime. Let me do another one. let me go x, y plus x to the third plus 4y to the fifth equals y. What the heck? Let's just add in a whole bunch of stuff here. So now I'm going to be doing implicit differentiation. Now notice I have 1, 2, 3 y's in this. 1, 2, 3 y's. So one of the things you can do when you're doing implicit is you're going to end up with 3 y primes. So this is kind of, since I have 3 y's, if you did it correctly, you should have 3 y primes. So let me go ahead and take the derivative with respect to x of both sides. 4y to the fifth. And then take the derivative with respect to x of this side. All right. So now this side, to find the derivative of this first one, notice it's x times y. I need to use product rule. And the derivative of x times y is the derivative of the first, so the derivative of x is 1. Don't change the second. Now we'll do the derivative of this, you'd leave the first one unchanged. Now the derivative of y is just y prime. So that took care of the xy, that expression right there. Now the derivative of x to the third, that's just 3x squared. Now the derivative of 4y to the fifth, that's 20y to the fourth. And then I need to add on my y prime. The derivative of this y is just y prime, and the derivative of a constant is 0. So notice I have 1, 2, 3 y primes. I started with 1, 2, 3 y's. I have that many y primes. You will always, always, always have that work out. So now I want to now treat y prime like a variable. So anything with a y prime I want to put on one side and everything else on the other. So I'm going to leave this expression, and this one. So these three are all going to go on to the left side. It doesn't really matter what side I put them on. Plus, these are already on the left side, so they're good. And then I'm going to move this to the other side, so minus y prime. And then I'll move the other stuff. So I have a 1 times y, which is just y, and a 3x squared. So I'll have minus y minus 3x squared. Move them to the other side. Now I can factor out a y prime. X plus 20 y to the fourth minus 1. That's factoring a y prime out of each of those. Equals minus y minus 3x squared. And then I divide both sides by this x plus 20 y to the fourth minus 1. So I'm left with minus y minus 3x squared all over x plus 20 y to the fourth minus 1, and I'm done. So those were two examples. I'm going to hit stop. I'll post this as its own video, and then I'll work through my PowerPoints, which I show a slightly different way. So let me